Welcome to Biochemistry YouTube channel. Karnataka SET 2013 Paper 3 Part 3. Question number 31. Which of the d orbital contribute to sigma orbital in a diatomic molecule? You know the d orbital, so dxy, dyz, dxz, dx square minus y square and dz square. Among these 5 orbitals, the axial bond is dx square minus y square and dz square. Whereas non-axial bond, these 3 orbitals are called as non-axial bonds. Hence, dz square, here dx square minus y square was not given. Hence, option A is ruled out, option B is ruled out, and option C is ruled out, and option D is the correct answer. dz square is known to form a better sigma bond. Also, the formation of sigma or pi bond depends on internuclear axis. The d subshell involves the axial bonds dx square minus y square and dz square. The non-axial bonds are dxy, dyz and dzxz. Question number 32. The 0 point vibrational energy of the bonded atom is given as. It is given as d0, 0 point vibrational energy is equal to 1 by 2 hw. Option D is correct. Question number 33. Predict the normal modes of vibration of O2, H2O and CO2. For O2, oxygen is a linear. It's 3n minus 5. It has 2 atoms, so 3 into 2 minus 5, which is equal to 1. For H2O, it's a non-linear. 3n minus 6. 3 into 3 minus 6 is 3. For carbon dioxide is a linear. So 3n minus 5, it has 3 atoms, 3 into 3 minus 5, which is equal to 4. Hence the answer is 1, 3, 4. Hence option D is correct. Question number 34. Sigma, sigma star, pi, pi star and n pi star transitions are observed in the region of. Here you see, so sigma, pi, n, pi star, sigma star. They have given 3 transitions. Sigma, sigma star, pi, pi star. So this is the energy. This is the energy in. This is energy. And third one is n pi star. So these 3 transition occurs. First is sigma sigma transition having more energy, E equal to h mu, that is, or E equal to hc by lambda. For sigma sigma transition, sigma star transition, it occurs at a far UV region, and pi pi star transition is near UV region, and n pi star transition having very less energy occurs at a visible region. Hence option B is correct. Question number 35. 250 MHz NMR spectrum of X shows a signal at 525 Hz upfield of TMS. What is its chemical shift? You have to calculate the chemical shift value. Chemical shift is given as frequency of the signal minus frequency of the standard divided by spectrometer frequency into 10 power 6. This is the formula. The compound is highly shielded, so the signal is at a upfield, hence the value will be negative. Here, hence option A was ruled out because the value is positive. Option C was ruled out because the value is positive. Hence, now you calculate the chemical shift value is a 525 divided by 250, which is equal to minus 2.1 ppm. Hence, option B is correct. Question number 36. The expected absorption band frequency of OH stretching, CH stretching and CO stretching vibrations for ethanol C2H5OH are observed at. Now the formula frequency equal to 1 by 2 pi C into force constant into M1 plus M2 divided by M1 into M2. If we calculate using this formula, the CH bond is, you will get the frequency for CH bond at 2900 to 2850, OH at 3400 centimeter inverse, CO stretching frequency 1200 centimeter inverse. Here is seen the ethanol, this graph. OH gives a broad peak at 3400, it's a OH peak, and CH peak is a 2900, is a CH peak 2900, and CO stretching peak at 1200 is a CO stretching frequency for ethanol CH3 CH2 OH. Hence option D is correct. Question number 37. Which of the following equation represents Maxwell relation? First, dou T by dou V equal to dou P by dou S. Dou T by dou V equal to dou P by dou S. It's a first one is a Maxwell relation. Dou T by dou P equal to dou V by dou S is also a Maxwell relation. Dou V by dou T equal to minus dou S by dou P. This is the relation. Hence third one is also a Maxwell relation. Hence option D is correct. All the three equations are Maxwell's relation. The partition, question number 38, the partition function is defined as, and is an indication of the number of thermally accessible states at the temperature of interest. Option A is correct. Question number 39, the ionic strength of 0.1 molal KCl solution. For KCl, it is K plus and Cl minus, Z1 equal to 1, Z2 equal to 1. So ionic strength I equal to half into M1 Z1 square plus M2 Z2 square, and M1 and M2 is equal to 0.1. Hence half into 0.1 into 1 plus 0.1 into 1, which is equal to 0.1. Hence option A is correct. Question number 40. For a distinguishable independent molecules, we write Q equal to Q power N. This is for distinguishable particle. For indistinguishable independent molecule, it will be given as Qn divided by N factorial. This is for indistinguishable particle. Hence option C is correct. Question number 41. For the following reaction, H2 plus Cl2 gives 2HCl. Delta G is given. The equilibrium constant K for the reaction at 298 Kelvin is. We know delta G equal to minus 2.3 RT log K. Hence log K is equal to delta G by 2.303 RT is a minus here. Hence log K, the value is given in minus, so minus into minus plus. So 262 into 10 power 3 divided by 2.303 into R is 8.314 into 298 Kelvin, which is equal to 45.91. taking antilog to K, you will get the answer 8.279 into 10 power 45. Option D is correct. Question number 42. The standard reduction potential of the electrode. Two electrode was given, Fe3 plus Fe and Fe2 plus Fe are given. The value will be in negative because it is a reduction potential. The electrode gets oxidized more easily. Or two electrodes were given, Fe3 plus takes 3 electron to give Fe potential, and another one is Fe2 plus 2 electron gives Fe. In this question, you see they are asking oxidation. They are asking about oxidation. Here Fe2 plus becomes Fe is an reduction. Hence option C was ruled out. Fe3 plus becomes Fe. It is also in reduction. Hence option D is ruled out. And oxidation, Fe becomes Fe2 plus. Fe gives Fe2 plus 2 electron. This is oxidation. A is the correct answer. The electrode Fe to Fe2 plus is oxidized more easily than Fe to Fe3 plus. Question number 43. The characteristics of Arrhenius equation. Arrhenius equation was given. This means here they are relating the rate constant and EA. Larger the activation energy, higher is the value of rate constant. No, option A is ruled out. In this equation, A is the pre-exponential factor, K is the rate constant, exponential of minus EA is the activation energy, and R is the rate constant, and T is the temperature. The magnitude of rate constant as function of exponential minus EA by RT. You know that the exponential is just the ratio of activation energy. The larger this ratio, the smaller is the rate constant. So here K is inversely proportional to EA. If the EA value increases, K value decreases. This means that a higher temperature and low activation energy favor large rate constant, and K is directly proportional to temperature. This you have to remember. Hence option B is correct. Larger activation energy, smaller is the value of rate constant. Activation energy does not show any dependence. C is ruled out. D is ruled out. Answer B is correct. Question number 44. What will be the effect of increase in ionic strength I on the rate constant of the reaction? The reaction was given which has a positive charge. The reactant has a positive charge and another reactant has negative charge, which gives product P. The rate constant does not change. The rate constant increases. The rate constant decreases. The rate constant initially increase and then decrease. Which option is correct? Here you see it's the relation between rate constant and ionic strength. Here log K is equal to log K naught plus 1.02 into ZA ZB and square root of ionic strength. This is known as Bronsted equation, and it predicts the plot of log K versus square root of ionic strength should be a straight line for an aqueous solution. The slope is nearly equal to ZA ZB. You have to calculate the product of ZA and ZB. That is the charge of first reactant and the charge of second reactant. You see, there are three special cases. If ZA and ZB have same sign, that is Za and Zb both have a negative sign and both have a positive sign, means the product is positive, and the rate constant increases with the ionic strength. In the given question, one is positive and one is negative, that is Za is positive and Zb is negative. Hence the product is Za, Zb is the value will be negative. Hence for Za and Zb having different sign, one is positive and another one is negative, means the product, the multiplication of Za and Zb will be negative, and the rate constant decreases with increasing ionic strength. You have to remember this one. Here in first option, the ionic strength is directly proportional to rate constant. That is, if rate constant increases, ionic strength also increases. In second option, the rate constant is inversely proportional to ionic strength. If rate constant increases, the ionic strength decreases. If one of the reactant is uncharged, Za and Zb is 0. That is, one of the reactant is neutral. It has no positive charge, no negative charge. That means the multiplication of Za and Zb is 0. And the rate constant is independent of ionic strength. The rate constant does not depend on ionic strength. So you have to remember these three options. Hence option here is the rate constant decreases, because in this option K is inversely proportional to ionic strength. Question number 45. The efficiency of an enzyme in a catalyzing reaction is due to its capacity. What is the purpose of using enzyme as a catalyst in the reaction? They are asking to form a strong enzyme substrate complex, to decrease the bond energy of the substrate, to change the shape of the substrate, to lower the activation energy of the reaction. The efficiency of an enzyme catalysis is due to its capacity to lower the activation energy of the reaction. Enzymes are biocatalysts which increase the rate of the reaction without being consumed in the reaction. In case of equilibrium reaction, catalysts help in attaining equilibrium quickly without disturbing the equilibrium. Hence, enzyme acts as a catalyst which lowers the activation energy EA. Here it's if it is an activation energy EA, then after adding catalyst, the EA will be decreased. It lowers the EA value after adding catalyst, enzyme catalyst. Hence option D is correct, to lower the activation energy of the reaction. Thank you for watching this video. We will meet in part 4 video. Thank you.